Hi, I am Sidhu. I am a faculty in Techshore Inspection Services. Today the topic I am going to take is material inspection and identification. How we will identify a material or how we will inspect a material once it is been received to our hands. See, when a steel plant or a steel supplier will issue a steel pipe or a steel plate from a steel plant to our project field, they will also supply a test certificate along with the raw material. The test certificates are containing certain details like heat number, which is the identification number for that particular raw material. That particular identification number will be furnished on the raw material through hard stamping. We have to trace this test certificate heat number with the raw material heat number at first. Secondly, information like dimension of the raw material, then chemical compositions of the raw material, thirdly, tensile strength of the raw material, then toughness of the raw material, then whatever in NDT test has been conducted, like a non-destructive testing examination has been conducted on a material, that can also be mentioned on the test certificate report. These are the general informations which are being furnished in a test certificate. See, these informations has been provided in the test certificate through the laboratory testings which is being conducted for that particular raw material by the steel plant in their plant. First of all, we have to review that one. Secondly, once the review has been found satisfactory, we can also take some sampling of the raw material and we can conduct the same testings in our laboratory in order to cross verify whether the material, chemical compositions, toughness, tensile strength, whatever it may be, which combine with the test certificate results. Say for example, in the case of chemical properties, chemical property is that property which when increases in a material will result in the increase in the mechanical properties of the material. So for example, in the case of a steel which is having a carbon content of above 0.3%, it is also being accompanied with certain other chemical alloying elements like manganese, molybdenum, chromium, nickel, titanium, niobium, then vanadium, etc. See, if a material is having carbon as its alloying element, then carbon will contribute the mechanical strength like tensile strength. It will boost up the tensile strength. About manganese, it will increase the toughness. Molybdenum is used in order to increase the creep resistance. Chromium, which is used for corrosion resistance. See, first of all, I will also simulate one more thing. I am having a 1 rupee coin. This one is a 1 rupee coin. This coin is a stainless steel material. It is not being corroded. Why? Because it is having chromium content. It is one of the resemblance of the chromium presence. Due to having heavy chromium presence, corrosion will not happen. And another one about nickel. Nickel is being used for low temperature services products. So for example, in the case of nitrogen will only exist in liquid form below cryogenic temperature, and cryogenic temperature is that temperature which works below 0 degrees Celsius, and nitrogen is a liquid, or nitrogen will exist only in liquid form if the material being handled is a nickel based material. Then about titanium and niobium. Titanium and niobium are used as grain refiners. See, I have listed some chemical compositions. Each and every materials are having certain percentage of chemical compositions. As the percentage of chemical composition increases, material strength also gets increases. But there is an adverse effect also. As the percentage of chemical composition increases, then the weldability of the steel will get poor. There is a formula in order to identify the weldability of steel named CEV value or carbon equivalency value. The formula is carbon percentage plus manganese by 6 plus chromium plus molybdenum plus vanadium by 5 plus copper plus nickel by 15. See, if the test certificates are providing certain percentage for these chemical alloys, then we can provide these percentage values in the CEV formula, and if the resultant value is greater than 10%, then it means that the weldability of the steel is very poor, or the weldability of steel is very challengeable. If the percentage of steel is less than 2%, then the weldability of steel is very good, but it is only being used for domestic purposes. If the percentage of carbon equivalency number is greater than 10%, then it could be used for refineries, steam plants, etc. So our main motto is to identify the chemical composition, carbon equivalency percentage. We can reveal it through the test certificates. That's the one thing. We can also actually trace the chemical composition through a special equipment named PMA machine or a spectrometer. PMA machine is that machine which is having a full form of positive material identification. That machine is being used in order to identify the actual chemical composition of the material. We can trace it through the machine, and we can cross verify with the test certificate whether they have provided the right information or not. Apart from this, tensile strength can be conducted on the UTM machine. A tensile value will be provided on the test certificate. That value is comparing with the actual result or not, we can cross verify. Impact test can be conducted. Impact test conducted values will represent the toughness of the material. Those values which are being provided in the test certificate can be compared with the actual values. And finally, once if every information provided in the test certificate are found satisfactory as per the actual values, then we can proceed for the manufacturing process. That's it. Thank you.